All right.
Okay.
Whenever you're ready.
I'm sending one right now.
Oh, okay.
It's
So you're
loading the attachment.
sending me an email of it?
Yeah, it's loading the attachment for me right now.
Tell me when it says sent.
All right, it's sent.
Kind of stuff are we looking at today? Oh, log. Okay.
Yep.
I think we started looking at these the other day, didn't we?
I
Yeah.
think we did. Except this one is just, I think we were just, what is it called? We were just changing them from
Yeah, we were doing
log to exponent.
basic logs 101.
Now we're solving them.
Right, now we're actually doing log problems. Okay. Now, when you're evaluating a log, I have found that it really helps to go ahead and add the variable x. It just,
Okay.
I'm not sure why. If I can figure out how to do it here. All right. In other words, if I say that's equal to x, now I can turn the whole thing into an exponential. All right.
Okay.
What do you want to do with that 71? What's a good thing to do with that 71?
I'm not sure.
Well, we didn't talk about the three most important properties of logs. Let's go through them. Let's go through the three most important properties of logs.
Okay.
If I have, let's use b. b to the x times b to the y. Excuse me. Let me back up here. The properties are the same for logs as they are exponents. So if I have the log of two numbers being multiplied together, that's the same as the sum of their logs. For example, if I had the log of 2 times 3, which is 6, that's equal to the log of 2 plus the log of 3. Okay?
Okay.
Same as the log, same as exponents, if you'll recall, and that's what logs are, exponents. When you are multiplying two bases with different exponents, you add the exponent.
Okay.
Now, if I'm doing division in the argument, a divided by b, then that's equal to the log of a minus the log of b.
Okay.
That's 1, that's 2. There's 3 of them. Let me give you an example of this. If I said the log of 12 divided by 7, well, that's the log of 12 minus the log of 7. And finally, the third one. If I take the log of a to the b power,
Yes.
it allows me to move that b down in front and become a multiplier. That is the same as log. Huh. And that's one way to memorize it. Log a. You see what I did? And an example of that would be the log of 2 cubed would equal to 3 times the log of 2. Okay, so these three rules, not the examples necessarily, but the three rules are key in solving these problems. So let's take problem number 1. Now I added the x just to make it a little bit easier, and I'll explain why in a second. First thing, let's use property 3. If I use property 3, what can I do with that 71?
I don't know. I'm not sure.
Well, there's property 3. The b is the exponent. What can I do with the b?
So wait, can you change that into 71 and then the log of
Yeah, exactly.
base 3
In other
comes
words, I
through?
can put it in front. It's the same thing as this.
Mm-hmm.
Now, if I say that's equal to x, now the real key thing here is what is that equal to? If I had
Log.
this, that, what is log base 3 of 3?
You would just solve that?
Well, I want you to recognize something. That's always 1, no matter what the base is or the argument. If I said
That's
log base 7 of 7, why? Because 3 to the 1 power equals 3.
mm-hmm.
If that was 17 and that was 17, 17 to the 1 power equals 17. So whenever your argument is the same as the base, your answer is 1. So what's the answer for this whole thing?
So is it just 71 equals x?
Yeah. And for this problem, I'm not sure having the x actually helps. I've always thought that it helped tremendously, but not if you have to manipulate it first. In other words, this really turns into that, and what you need to be able to do is look at that and call that 1.
Uh-huh.
This whole thing is 71 times 1.
Okay.
Okay? So let's dispense with the x for the moment, just because they're trying to teach you some other principles here. Now, as long as I've got these on the page, let's do 1, 5, and 9. And then I can, in other words, I can't look at 2, 6, 10, and 14 unless I erase all this stuff.
Mm-hmm.
Before I erase it, I want you to memorize these, 1, 2, and 3, to memorize them well. There's another principle in logs. If I have b to the log base b of anything, that's equal to the anything.
Okay.
So what's this equal to?
Just x?
There's no x there. There's a 7,
Oh, so
so
is it
it's
just
equal
putting
to 7.
this?
It's
Oh.
equal to 7. In other words, I've got
Oh.
2 to the log base 2 of 7. If I had 3 to the log base 3 of 12, the answer is 12. In other words, whenever this is the same as that, and the exponent's got logs in it, then your answer is always whatever that number is.
Okay.
In this case, 7. All right, let's look at number 9. Well, first of all, let's see, what are we looking at? We're looking at log base 6 of 18 minus log base 6 of 3. So which rule are we going to use? And
The second one?
rules, you got to be able to go both ways. In other words, you got to know, you got to be able to convert the right side to the left or the left side to the right equally well. They're going to ask you both ways every time they ask you about these things.
Mm-hmm.
Now, what they're giving you here is the right side. They're giving you that.
Okay.
So put it back in the form of the left side. What do you get?
Isn't log base 6 of 18 over 3?
You got it, which is the log base 6 of 6. Now, what is that?
1.
So that whole thing is 1. Okay. Now, can I erase these rules?
Yeah, you can. I have them
Run
written
them
down.
down. Let me erase them, and let's go back and do 2, and let's do these in proper order. Why is my computer giving me trouble? That's never a good thing.
Mm-hmm.
You can't close out a window. Any suggestions?
What is it? Just frozen?
Appears to be, although it's lighting up. It just won't close this window out that is my screenshot.
I don't know. If you go to Task Manager, can you close it? Control or delete.
Yeah, maybe. Control. Let's see. Oh, yeah. I'm not even sure what this software is called. Gosh, it doesn't appear to be under my task manager.
It doesn't?
Well, I don't see it. Close that out. I don't want to close out go to meeting. Let me close out OneNote. That might help. Let me close out this photo. Okay. Now, I got to reopen the photo. Now let's see if I can do that. Now I closed out everything. I got to reopen my Gmail. Sorry about this, Sam. Hold on a minute.
That's fine.
I'll get it back up here, I think. Unless I'm going to have to reboot my computer, which it looks like I might have to. Chrome didn't shut down properly. Let's see if I can restore it. Might be one of those things, the only thing you can do is reboot it. But, yeah, it's not like it. Well, maybe.
There it goes.
Yeah, there it goes. Yeah. See if I can reopen it. But everything seems to have slowed down tremendously on my computer. I cannot scroll horizontally on that. Want to read to me problem number 2?
Did we do 13?
We didn't do 13. Let's do 13.
All right, I'm going to write it down real quick.
All right, let's deal with the exponent first. The exponent is log base 3 of 5 minus log base 3 of 4.
Mm-hmm.
So simplify that.
Isn't it just log base 3 of 5 over 4?
Yeah. Okay, now that's what we're going to stick in place like that. So that's going to be 3 to the log base 3 of 5/4. So what does that answer?
Isn't the whole thing just equal 5/4?
Yep. So every one of these questions is applying these 3 rules of logs and more. There's a couple of more that aren't in those 3 rules, but just as important. For example, 2 to the log base 2 of 7, you need to know that that's 7. And log base 3 of 3, you need to know that that's 1.
Uh-huh.
There's a few things you need to know. What's 2 say? What does 2 say? In other words, I can't get to 2,
okay.
6, 10, or 14.
Do you just want me to send you a picture from?
You can verbalize it, can't you, or not?
I can. Yeah, it's log base 2 of 2, and then to the power of negative 13.
So what's that answer? First of all, what's the first step?
I just blanked.
Those exponents. Get rid of those exponents. What can I do with that negative 13?
I'm not sure.
Bring it down and put it in front.
Oh, I forgot about that. So then you have negative 13 log base 2 of 2.
Which is? What's equal to?
1, or it's negative 13.
Yeah. Okay. Why don't you just read the rest of it?
Okay, just all of them?
Well, we only have 10 minutes. Let's do 3. Let's just do them in order. Whatever 3 is. If it's on.
Okay. Natural log of e to the power of negative 4.
Okay, natural log of e to the negative 4.
Yeah.
First of all, what's natural log mean?
Isn't that just log? What is that?
Log
Is that log
base.
base e?
In other
So
words,
that's
you can have log base 2, you can have log base 7, you can have log base e. E being the number 2.71. That is written natural log. So when you see natural log, it's the same as what I got circled down here lower right. That is the log base e. Okay. So what's the first step I want to do on this?
put the 4 in front, the negative 4 in front of it.
Good, you're learning. So it's minus 4 times natural log of e. What is the natural log of e equal to?
1.
Okay, good.
So then it's all equal to just negative 4.
You got it?
Cool.
What next?
Okay, the natural log of e to the power of negative 2. Or no, not negative 2, to the square root of 2. Which is just the square root of 2.
So you're getting the hang of it quickly. Okay. Here's the next one you want to do. We don't have to do them in order of this page. You just tell me which ones.
Log base 2 of 6 times log base 6 of 4.
Serious? Times?
Yeah. It's on page 321, also in that textbook.
Okay, I'm thinking about this for a second, see if I can figure out how to do it. Are you familiar with the change of base?
No.
Change of base says that the log base 2 of 6. What kind of calculator do you have?
Oh, I don't have my calculator with me today. I gave it to a friend for a math test.
You have an Inspire or a TI-84?
I have an Inspire usually.
Okay. If you had a TI-84, you couldn't do this without using change of base formula. The change of base formula is just the log of the upper number divided by the log of the lower number. Like that.
Okay.
Times, same thing. Log of the upper number divided by the log of the lower number. Now I'm understanding how we're going to do this problem. Well, remember, each one of these is just a number, right? You could get these out of your calculator. Well, that's the same number as that, so I can cancel it. Now I have the log of 4 divided by the log of 2. That's my answer.
It is?
Yeah, notice you can't use the division property. The division has to, if it was the log of 4 divided by 2, then that would be the log of 4 minus the log of 2. But because I'm dividing the logs, that's got to be my answer. I can't simplify it anymore. At least not that I can tell. Yes, I can. Yes, I can. Let's look at the log of 4. The log of 4 is actually the log of 2 squared, right?
Yeah.
So I can write that 2 log of 2, and I'm dividing it by log of 2. Those cancel, and this is equal to 2.
So it's just equal to 2?
Uh-huh.
Okay.
this whole thing here. And you could do it if you had your Inspire, you put it in and multiplied it out. You might not get 2, but you get 1.9999 or 2.00001. In other words, there might be some rounding off going. But if you use the rules of logs, you can break this all the way down to where I just had a number.
Okay.
Okay, what else you got? These are good here. These are hard.
Okay.
These are challenging.
There's log base 3 of 8 times log base 8 of 9.
Again, we can't really handle it when it's different bases. So we want to convert it using the change of base form.
Mm-hmm.
So this expression becomes what?
Was it log of 8 over log of 3 times log of 9 over log of 8?
Yeah, and these are common logs. In other words, the base on these logs is 10.
And then you can cancel the 8s out.
And then use the same trick we did before. So here's what we have. The log of 9 divided by the log of 3. How else can we write the log of 9?
Log 3 of 3 squared.
Like that. That allows me to bring the 2 in front. And now the log of 3's cancel, and again my answer is 2.
Mm-hmm. Okay. There's one more. So it's e to the power of log. Here, I'll just take a picture of it.
No, that's all right. Go ahead. We're almost out of time, and unfortunately I have a 7 o'clock. So
okay. E to the power of log.
Log or natural log?
Log base e squared.
Like
and then
this?
And then there's a 9 after that, yeah.
Like that?
Yeah.
Log base e squared
of 9.
Of 9. So the argument is definitely 9, right?
Mm-hmm.
And the base is definitely e squared?
Mm-hmm.
Not sure how to handle a base. Let's convert it. Let's see. That would be the log of 9 over the log of e squared, which I could write like that. So that's what that is.
Mm-hmm.
And I've got it all
to the power of e.
Well,
e to the power.
Yeah, e is being exponentiated to that.
By that. Mm-hmm.
Yeah. This change of base formula is a little tricky. If I have that, I've told you that that's equal to the log of A divided by the log of B. But believe it or not, you can make that any base you want. It's also equal to that. It's also equal to the log base 17 of A divided by the log base 17 of B. The amazing part is all of these ratios are the same. They're exactly the same number. Okay?
Okay.
So when I used my change of base formula, I should have used natural logs, not common logs. So let's change it to natural log. And you're going to see that nice things happen. Let me erase all of this over here on the left so that I have room to write.
Wait, so is it just the natural log of 9 over 2?
Well, let's first of all deal with the exponent. Here's our problem, right?
Yeah.
So the exponent becomes this.
Mm-hmm.
So what we have is e to the natural log of
9.
9 over 2 times 1.
Mm-hmm. And is...
Well,
Don't know how to
I
go
can
further.
take that 1/2. In other words, that's the same as 1/2 there, correct?
Yeah.
I love these problems. They are challenging. It really makes you think. You really have to know your rules of logs. Now, because that 1/2 is in front, I can make it the exponent of the 9, right?
Mm-hmm.
Now, what's the square root of 9?
3.
So now we have e to the natural log of 3. What's that equal to?
3.
There you go.
That's it.
Uh-huh.
That
That was tricky. That was very tricky. You had to use the change of base formula. Furthermore, you had to know that you could use common logs or natural logs. And you want to use natural logs whenever you see the letter E. If you see
Uh-huh.
E and you have a choice, always use natural log.
Because you can cancel them out.
Yeah, because natural log of E is 1. Common log of E is, I have no idea, some irrational number. But if I got the natural log of E, or E to the natural log of something, in other words, I've got an E as my base, so I want to make sure my exponent is natural log, not common log.
Mm-hmm.
Okay. Sam, I'm going to let you go,
Thank you.
and I'll talk to you next time.
Bye.
All right.